Hey everybody, it's Miss Moran and I'm back to talk to you about a new unit of study we're going to be on for the next 2.5 weeks, addition and subtraction. This week focusing on addition. Students are very excited about this because they're thinking easy street, they already know how to add, this should be a piece of cake. And in truth, yes, we do already have algorithms and strategies for addition, so this shouldn't be that difficult. But we're going to be doing addition in problem-solving scenarios and also using estimation. We're also going to be looking at using a couple different strategies, one of them being partial sums and one being our traditional algorithm of place value, which also involves regrouping. So I'm going to show both of these, especially partial sums. This is one most parents will probably not be as familiar with and would probably not encourage students to use as a first option when it comes to adding. But there is a lot of value in it, so we'll talk about that. All right, here's our question we're going to be working with today. It says Heidi and her brother were playing Monopoly. Heidi had $2,822 in her bank. Her brother had $1,354 in his bank. How much money did they have all together? So the first thing is identifying that we're talking about an addition question because we're looking to combine two values into a larger sum. All right, so we're looking at $2,822. We're going to be adding to that $1,354. All right, so first thing we're going to be doing in a partial sum strategy is showing that when we add, we're going to be combining things that are alike. So I told students, when you look at these numbers, when I think about my addition, I can add small numbers in my head, numbers up to the teens or so. But when we're adding 2,822 plus 1,354, that's not something I can just do in my head. Only I kind of can. If we think about how we would add this, the most logical way is to add it with things that are like it. So we're going to be looking at this 2,822 and thinking about it in expanded form. So this 2 really means 2,000. The 8 means 800. One of those 2's means 20, and the other one means 2. So in expanded form, we've got 2,822. Also, we have 1,354. That's 1,000 plus 300 plus 50 plus 4. So if I ask students to add these together, the logical thing is to combine things that are alike. So I'd add my thousands together, I'd add my hundreds together, and my tens and my ones. Need a second hand. Okay, so looking at these, if I added my thousands together, 2,000 plus 1,000, that's easy to do, that's 3,000. 800 plus 300, this gets a little bit trickier, but if I can do 8 plus 3 is 11, I can think of that as 1,100 or 1,100. 50 plus 20, 70, and 4 plus 2 is 6. And I just want to combine these partial sums. That's what we call it, partial sums, because it's part of the problem, added together. 3,000 plus 1,100 plus 70 plus 6. So the good thing about partial sums is it lends itself to students understanding that they can approach these problems from a mental math standpoint. And as students get a little bit older, starting in 4th grade and moving into 5th and middle school, we want students to have a good, strong mental math background. So we can add these together, and what students will actually see is this is sort of the foundation for where we come up with our traditional regrouping algorithm. So noticing here that when these hundreds have gone past basically 999, once it's gone into the next 1,000, we're going to be regrouping and thinking of this 3,000 not as 3,000 anymore, but taking this 1,000 here and combining it over here. So it's really going to be 4,000. That'd leave me with 176. Okay, so I'm combining those values there. Now our traditional algorithm is going to require us to line up the numbers. My 1st grade teacher always told me, line them up. So we line them up. But we're going to understand really why we line them up, not just because we're being obedient to our teacher, but because there's a reason that we do that. The reason we do it is so that we can do exactly what we did over here. So that I can make sure my thousands are added with my thousands, my hundreds are added with my hundreds, my tens are added together, and my ones are added together. 4 plus 2 is 6, just like it was over here. 5 plus 2 is 7, just like it was over here in the tens. 8 plus 3 is 11. Now here's where we have the problem. I can't put 11 down here because it goes over the 1,000. So I'm going to put 100 of it down here, and I'm going to take the extra 1,000 and I'm going to regroup it into the thousands place, just like I basically did here, looking at that extra 1,000 and pushing it over here. So 2 plus another 2 is 4. So I got 2 answers, and they are the same answer doing 2 different strategies. So it's a good way to confirm my answer by doing it 2 different ways. Also, I'm understanding where this regrouping comes from. Okay, I don't just put that 1 up there just because my teacher told me put a 1 up there. I put it up there because I see that when I go over 1,000, I end up needing to regroup. So this is sort of the foundational understanding of what we're doing when we do this strategy over here. Okay, so when it comes to adding, as we said, most students are fairly comfortable with addition strategies. So how do they make mistakes? There's 3 ways students make mistakes, and none of them have anything to do with actually adding numbers. Number 1, they don't usually copy numbers correctly from the problem. If they're rushing, sometimes they'll switch numbers around and put the digits in the wrong places. Another thing is messy numbers. So 6s look like 0s, 1s look like 7s, 4s look like 9s, and students can't even read their own numbers enough to know what numbers they're adding. And last, the students don't line up the place values. And when they don't line up the place values, they end up adding things together that shouldn't be added together. Okay? They end up making sure that their thousands aren't lined up with thousands. You might have thousands lined up with hundreds, and then that becomes a problem. So if we can be aware of these mistakes and be making sure that we don't do these things, then addition will be something we'll be a lot more successful with. All right, one more thing we're going to be doing this week and next week is estimation. Okay, and we're going to use our skill from our last unit in rounding to help us with estimations. It takes 2 days for the Smith family to travel to Nashville, Tennessee, to Key West, Florida. On the first day, the Smith family drove 264 miles. On the second day, they drove 732 miles. How far is it from Nashville to Key West? So the reason we're going to do an estimation is because it's going to help us answer if our, or determine if our answer is reasonable. If our answer is not reasonable, then we're going to go back and figure out where we made our mistake. All right, so we're looking for 2 different days combining the mileage. So this is 264 plus 732 miles. Okay, and we're going to add that up. So first thing I'm going to do is I'm going to round these numbers and decide how I'd like to round. So both of these numbers are in the hundreds, so I feel fairly certain that rounding to the nearest 100 is going to be an acceptable strategy. Sometimes we'll learn it's important to round to smaller places, but we'll talk about that more specifically next week. All right, so we're going to round this to the nearest 100. That's between 200 and 300. That's going to round up to about 300. Okay, 732 is between 700 and 800 and rounds down to 700. So when I add 300 plus 700, it's going to give me about 1,000. That does not mean my answer has to be in the thousands. It just means I want it to be about the size of 1,000. And we're going to talk about why that estimation becomes so important. Okay, so as a good student, I'm going to go ahead and take that 264 and add 732 to it. Using my traditional algorithm, we're going to do 4 plus 2 is 6, 6 plus 3 is 9, and 7 plus 2 is 9, so 996. Okay, just for a little bit more practice here, I'll show you the partial sums. So we're breaking 264 into 200, 60, and 4, and 700, 30, and 2. Okay, so a good benefit to teaching students, again, about partial sums is to realize that they can do this without having to write it out on paper, especially a problem like this, which doesn't actually require any regrouping. So I can see this as 996, which is 996. Same thing I got over here. So I'm going back to my estimation. I thought I was going to get something around 1,000. I have something very close to 1,000, so that tells me my answer is reasonable. It doesn't tell me my answer is absolutely correct. We could do 264 plus 732 and think 4, 2 is 8. Whoops, I messed up on my multiplication. They don't know that. 6 plus 3 is 9, and 7 plus 2 is 9. Okay, so I got 998. Still reasonable. Okay, so doing my estimation is not going to help me with specific computation, but here's where it does help me. If I did 264 and I did 732, I didn't line those up very correctly, like I said students will often do. And we just add, and we say 2, 7, 13. Okay, I got 3,372. Yikes, nowhere near 1,000. So this is where I tell myself my answer is not reasonable. It's nowhere near the same magnitude of the size of the number I want to get. I'm trying to get a number close to 1,000. I got something in 3,000s. So that tells me my answer is not reasonable, and I need to go back and figure out where I made my mistake. Okay, so in this case it was I didn't line up my numbers. Sometimes it might be I was supposed to regroup and I didn't, and I put both of the numbers at the bottom. So things like that will help us with reasonableness. This partial sum strategy is going to be very important for understanding as we get into larger numbers and multiplication. In our next chapter, when we multiply 2-digit numbers and 3-digit numbers and 4-digit numbers, we're going to want students to understand how we break up those numbers into simpler problems, and this is a good step in moving into that direction. All right, thank you so much for watching, and good luck with addition this week.